Hey guys, today we're going to take a look at arithmetic sequences. And all an arithmetic sequence is, it's a sequence of numbers that has an adding or subtracting pattern. For example, 4, 10, 16, 22. That has an adding pattern. It goes up by 6 each time. What about this one? 45, 40, 35, 30, and so on. This one has a subtracting pattern. And that pattern is what we call a common difference. So the D, and I'm going to label that, or common difference of the first pattern is plus 6 or 6. The D, or common difference of the second pattern, is minus 5 because we subtract 5 each time. Well, this behaves a lot like a linear function in that it has that adding or subtracting pattern. So that also means we can write equations for these situations. So before we actually get into that, I want you to write these down. There are two types of equations we can write for these. We can either write a recursive formula, or we can write an explicit formula. So let's write those, and again, then I'll explain them. So the recursive formula is a little n, and we say a sub n equals a sub n minus 1, that means make the n minus 1 small, plus d. And we're going to write them before I actually explain what they mean. So a sub n for the explicit formula equals a sub 1, little 1, plus n minus 1 in parentheses times d, which we already know the d is the common difference. So these are some things that we've not seen before. So let's look at the recursive formula. Recursive formula. A sub n simply means the number of the term. So if I put a sub 1, that means the first term. If I put a sub 50, that means the 50th term. So that just means the number of the term. A sub n minus 1 means the previous term, the one before what we're trying to find now, and we know that D means common difference. So to find the term now, we take the last term and we add the common difference or subtract if it's negative. Now let's look at the recursive formula. The explicit formula. So we learned just now that a sub n means the number of the term. Well, guess what a sub 1 is? That's the first term. So it's the very first number in our sequence. N, again, just stands for number, like 1, 2, 3, 4, 5, 6, 7. It's the number of the term as well. And we know that D stands for common difference. Okay. And then I also want to tell you when you're going to use these. The recursive formula simply helps you find the next term. Just like to complete these terms up here, I said 4 plus 6 is 10. 10 plus 6 is 16. 16 plus 6 is 22. Recursive just means you keep adding or subtracting. The explicit formula helps you find a specific term. So that's going to be good, like let's say you want to find the 500th term or the 20th term. It helps you find something specific. So now let's take a look at how you're actually going to use these in today's lesson. So let's look at the first example. For the first example, I want you to write negative 30, negative 40, negative 50, negative 60. That's our first sequence. The first number is negative 30, the second number or second term is negative 40, and so forth. So first let's find our common difference. And your problems will be set up very much like this for your practice. And you can use these for your practice and your quizzes, these notes. So our common difference is we subtract 10 each time. So now let's find our recursive formula. Okay, so first I write it. A sub n equals a sub n minus 1 plus d. So a sub n equals a sub n minus 1. What is our common difference? It's minus 10. So this is my recursive formula. Okay, now let's take a look at our explicit formula. So again, I always start by writing that general formula. A sub n equals the first term plus n minus 1 times d, which is my common difference. A sub n stays. What is our first term? In this sequence, it's negative 30. That's my first term. Plus n minus 1 stays the same. And what was our common difference here? Negative 10. Now, I've plugged everything in, but remember, in math, we always simplify. So I can do the distributive property and combine like terms here. So negative 30 plus, and I'm going to multiply everything by negative 10. So negative 10, oops, I actually shouldn't have written that plus yet. Let me erase that. So n times negative 10 is negative 10n, and negative 1 times negative 10 is positive 10. Well, now I can combine, this is stuff we've already done, negative 30 plus 10 is going to give me negative 20. Let's try one more like that. So example 2. Let's say we have this pattern, 15, 20, 25, 30. Okay. First of all, let's find our common difference. It looks to me like we are adding 5 each time. So our common difference is 5. D equals 5. So first let's find our recursive formula, the formula we would use just to find the next term. So the recursive formula, a sub n equals a sub n minus 1 plus d. So now let's plug in our common difference, which is positive 5. So this is our recursive formula that we use just to find the next term. Now let's find our explicit formula, which we can use to find any term in the sequence. A sub n equals the first term plus n minus 1 times our common difference. So let's plug in our information. So first I need my first term. So a sub n equals, my first term is 15, plus n minus 1 times my common difference, which is 5. And last we simplify. 15, 5 times 1n is positive 5n. 5 times negative 1 is negative 5. And now I can combine like terms. So 15 minus 5 is 10 plus 5n. Now I know I wrote that different than what I did last time. Last time I put the variable first. I just want to show you that both ways are correct, so be prepared for either way. But this is our explicit formula. Then in today's work, I'm going to give you a formula and ask you to use that to find information. By the way, that's the whole reason we write equations, because it shows relationships and it helps us find information we need. So let's say I give you this. A sub n equals 75 plus 10n. So when I look at that, I can see that my common difference is 10, but this is an explicit formula, so 75 is not my first term. Okay, so be careful with that. So I might ask you something like this. Find your first 5 terms in the sequence. So what you do, let's do this. A sub 1, A sub 2, A sub 3, A sub 4, and A sub 5. That's just first, second, third, fourth, fifth term. What that means is I want to plug 1 into that equation, then 2, then 3, then 4, then 5. So this becomes 75 times, plus 10 times 1. Well, 75 times 10 is 85. You got two things you can do here. You can keep plugging stuff in, or you can use your pattern to complete your terms. So 75 plus 10 times 2 is 20 is 95. 75 plus 10 times 3, 10 times 3 is 30, that's 105. What's 105 plus 10? You see it's going up by 10 every time. 115 and then 125. But what if I don't ask you to find the first 5 terms? What if I ask you to find something like A15, which is the 15th term? So that becomes 75 plus 10 times 15. 75 plus 10 times 15 is 150. And 75 plus 150 is 225. So the 15th term in this sequence is 225. And then let's look at one more. I might give you the first term and the common difference. So in this case, I'm going to tell you the first term is 35 and the common difference is 4. If I do that, I might ask you what the first 5 terms are. Oops. So look at this. I have the first term. It's 35. Well, the common difference says I add 4 each time. So 35 plus 4 is 39. 39 plus 4 is 43. 43 plus 4, I may have said plus 9, I'm not sure. 39 plus 4 is 43. 43 plus 4 is 47. And 47 plus 4 is 51. So that's how you can use that information to find the first 5 terms. Then I might ask you to find the recursive formula. So what you do is you plug your common difference into your formula from above. So A sub n equals A sub n minus 1 plus 4. And then I might ask you to find the explicit formula. So you write your formula and plug in your information and simplify. My first term is 35 plus n minus 1 times my common difference of 4. So I'm going to do the distributive property to simplify. Plus 4n minus 4, and then I still have to combine those like terms to get 4n. 35 minus 4 is positive 31. So that's your recursive formula. So these are the different ways that we could interact with or think about arithmetic sequences. They have an adding or subtracting pattern, which is our common difference. You can write a recursive formula, which helps us find the next term, or an explicit formula, which helps us find specific terms. And then we went through how to use that information in different situations. So please take your time, use your notes to help you, and I'll talk to you guys later.